Hi everyone, thank you for joining us today. My name is Haley Deshane and I'm the events coordinator here at Eco Canada. Welcome to the Empowering Indigenous Communities Deep Energy Retrofits and Energy Building Code Compliance webinar funded by the Government of Canada. Before we get started, I would like to take a moment to recognize the traditional Indigenous land where Eco Canada's office is based in Calgary. At Eco Canada, we're committed to working towards respectful acknowledgement, collaboration, and reconciliation with Indigenous peoples across Canada. This starts with acknowledging our honor and privilege to live and work within the Treaty 7 territory. Today, we are presenting from the City of Calgary, home to the Métis Nation of Alberta, Districts 5 and 6. We would also like to take this time to acknowledge the traditional territories and oral practices of the Niitsitapi, home of the Blackfoot Confederacy, which includes the Siksika, the Piikani, the Kainai First Nations, and the Tsuut'ina and Goodstoney, which include Chiniki, Bearspaw, and Wesley First Nations. I also want to go over a few housekeeping guidelines for today's session to ensure that everyone can enjoy and participate in our session effectively. So all participants are muted, so please check your audio settings to ensure you can hear us properly. If you are experiencing any technical issues, please use the chat function on the left-hand side of your screen and we can do our best to resolve it for you. Today's webinar is being recorded and will be available for your viewing in 24 hours. Any questions that you have about the presentation or today's topic can be submitted through the question box, and at the end we will have a dedicated time to answer any questions from the audience. Finally, we really want to know what you think about our webinars and how we can keep improving them. So you'll be sent a short survey after the webinar ends. Please let us know what you think of it, or if you have any comments or suggestions about the webinar. Eco Canada's vision is to build the world's leading environmental workforce. Eco Canada seeks to help environmental workers succeed at each step of their career journey. To do this, Eco Canada has developed programs tailored to individuals at different stages of their career. For those looking to enter the environmental workforce, Eco Canada provides training through the BEAR program. You can learn more about this on the Facebook page. I'll put the link in the chat. But Eco Canada also provides accreditation for environmental programs at post-secondary institutions and provides opportunities for new workers to break into the environmental sector through wage funding or co-op students and recent post-secondary graduates. For those already employed as environmental workers, Eco Canada provides the Environmental Professionals EP and Environmental Professional in Training EPT certifications and EPT students. Lastly, Eco Canada provides opportunities for those with vast experience as environmental workers to provide guidance and direction to Eco Canada's products and programs through advisory committees and emeritus memberships. I would now like to introduce you to our speaker. Joining us is Adam Trovato. Adam is Simplify Energy Consultants co-founder and principal energy consultant. Adam's passion for building science and energy efficiency have led him to manage hundreds of distinct energy efficiency and management projects over the past decade for commercial, Indigenous, municipal, and institutional clients. With a keen focus on delivering projects that are outcome-based, Adam ensures that all projects have a start-to-finish continuity while achieving the client's goals. In doing this, Adam has helped Simplify's clients access over $50 million in energy efficiency and sustainability funding, consistently delivering on budget, on time, while supporting the clients to ensure the projects are as easy on our clients as possible. Specific to Indigenous communities, Adam has worked extensively in supporting these groups set, plan for, and achieve their energy efficiency sustainability goals by performing detailed energy analysis, energy audits, renewable energy analysis, community energy plans, and funding applications. In total, Adam has worked with over 30 Indigenous communities throughout Western Canada, including but not limited to Bearspaw First Nations, Alexander First Nations, Paddle Prairie Métis Settlement and the Métis Nation of Alberta, and the Tall Cree First Nations, and more. Adam's dedication to the sustainability industry can be illustrated through his volunteer experience as the Vice President of the Association of Energy Engineers, the Alberta chapter, and as a board member for the Alberta Energy Efficiency Alliance, which, along with his professional experience, earned him the 2023 Young Energy Professional of the Year Award for the Association of Energy Engineers. Over to you, Adam.
Thank you. That was quite the introduction, and I appreciate that. I'll just dive right in, everyone. So, thanks again for joining us today on this webinar to learn about deep energy retrofits and building code compliance in Indigenous communities. This is a pretty large topic, so I'll have to go relatively high level over most of it, but we'll definitely learn a lot about retrofits and energy efficiency throughout. Okay, so for the agenda today, it should run kind of about 45 minutes of content and then some time for questions at the end. We'll start with some introductions, and then we'll roll into an overview of the deep energy retrofits, where we'll dive into the retrofit process, then into different approaches to retrofits, some considerations when going about retrofitting a building, and then we'll dive into retrofits and building code, look at a case study, discuss some lessons learned, and then wrap up talking about some of the available funding and deep dive into the Deep Retrofit Accelerator initiative that's available to Indigenous communities in Alberta and is a very opportune funding opportunity for those of you who are in Alberta. Okay, so let's dive in. If you could switch to the next slide. Okay, I'm just gonna, this is basically the introduction that Haley, you gave me, so we can just go to the next slide and we'll go right into the content. Okay, fantastic. So, so what is a deep energy retrofit? So a deep energy retrofit, or you'll often hear or see DER, is a holistic renovation process that achieves a dramatic reduction in energy and or greenhouse gas emissions. So, typically you'll see the number of 50 to 90% to classify it as deep, but it really is just semantics at that point. The main idea is to have a very large and significant retrofit to your building that kind of fundamentally changes how it operates from an energy perspective. And it typically looks at all aspects of the building or most aspects of the building rather than just a single area of the building like the lighting or something like that. So, most building owners have different priorities of what, motivates them to go about a deep energy retrofit. But, some of the common benefits are a utility cost reduction. That's one of the major drivers for most people. Energy prices keep going up. And as a result of that, utility bills go up. And this is one of the mechanisms in order to de-risk your building from that price increase. There's the environmental benefits that are associated with it, as in a lot of places, there's a direct correlation between, electricity or power use and how much environmental impact the building may have. So as well, retrofitted buildings have improved air quality and thermal comfort, making them healthier and more comfortable. And when retrofitting a building, we can adapt the building to respond quite a bit better to extreme weather events such as fire, flood, and extreme temperatures. For example, if you're a remote community, you may have often power outages and brownouts and things like that. When you retrofit your building, you can put on solar and a backup power, a backup generator or some battery banks or something like that, and then provide yourself that backup power that gives you resilience to blackouts and brownouts that might happen during extreme weather events. As well, retrofits often create significant economic opportunities for the local economy and workforce. We'll dive more into that later. And then when done properly, retrofits can have a large community impact through integrating local knowledge, skilled labor, and goals into the project effectively. All in all, yeah, there's vast, benefits to deep energy retrofits that we can see on any given project. Next slide, please. Okay, so diving into the types of buildings and types of technologies that are relevant for deep energy retrofits. Retrofits can happen on basically all building types. It's just the scale will change depending on the building. So this includes homes, apartments, commercial buildings like office towers and retail stores, community buildings such as an admin building or a communiplex, as well as specialty buildings such as a cultural building or a heritage building that might be in a community that holds significant value and significance outside of the structure itself. So each building does present different needs, which will.
Hi everyone, sorry we seem to have lost Adam. We'll just pause here for a second and he'll log back on.
Hey everyone, I'm very, very sorry about that. My internet cut out, so I'm now on hooked into the phone, so that should be all for the technical difficulties. Um, I do apologize about that. So I might need to speed up a couple slides here, but I'll dive right back in. So in terms of the technologies used for a retrofit, um, we probably have some familiarity, but it really is everything in the building that contributes to energy use. So we see building envelope improvements, which goes from high performance insulation and air sealing to doors, triple pane windows, things like that. HVAC systems such as boilers, furnaces, variable frequency drives, into more advanced stuff like heat pumps, ERVs, stuff like that. And then you've got your building controls, automation, lighting, renewable energy like solar and geothermal, and on-site storage like and EV chargers and things like that. So we do have a wide range of technologies that we bring together to make up a deep energy retrofit. Next slide, please. Okay, so I don't love this image honestly, but it is something that you'll see often in deep energy retrofits, and it does serve a purpose. So it's meant to show sort of the order of priority or how you should go about retrofitting a building in order to do things the most efficiently and to limit locking into your building basically into something that might not be relevant in a few years. So from a cost perspective, you're going to start at the bottom and you're going to do the low hanging fruit. This is typically things you can do yourself or with your team, doing just little things, switching thermostats back at night, making sure the lights are turned off at night, like basically the small operational changes to your building and low hanging fruit that you can just identify and immediately fix. Then you typically are going to want to make sure that you're on LED lighting. At this point, it's just a no-brainer, um, and it just saves a ton of electricity. Air sealing and weather stripping, so going through your building and making sure, without replacing things necessarily, that the building is well sealed and that there's not, just air escaping through the bottom of your doors or through windows and things like that. Then you're going to want to do water heating, appliances, um, and move into, more deep building envelope stuff like, doing your walls, insulation, foundation, roof, then deep HVAC retrofits, and then more large envelope projects, the really expensive stuff. And then once you've got your load as low as possible, because once you've gone through all these steps, your building consumption is going to be as small as possible. Then you're going to size your renewable system to that small load, and then therefore your building should theoretically be net zero or as sustainable as possible. Next slide, please. Okay, so there's a lot of info on this slide. And this is meant to show the different approaches to retrofitting a building because it is not one size fits all in pretty much any circumstance. So, let's starting at the top. You've got the deep energy retrofit. So that's sort of what we're talking about today. But that's, a comprehensive overhaul, like I said, of your building to achieve 50 to 90% energy reductions. All measures are implemented simultaneously in this instance, including envelope upgrades, HVAC replacement, lighting, renewable energy systems. So this is ideal for projects with a large budget, and when the building is unoccupied or undergoing a major renovation anyway, because it is quite invasive. Something like this, you'd have to move people out of the building in order to do. In terms of advantages, it maximizes the energy savings and comfort improvements. It gets it all done at once, and the overall project timeline is shorter compared to a staged approach where you kind of keep the building more operational. The challenges are um, high upfront costs, and it does require careful planning and coordination with contractors and internally. The next is a staged and incremental retrofit. So in this approach, energy measures uh, are implemented in phases over several years. For example, your envelope improvements might be completed first, following your HVAC upgrades, and then later your renewable energy integration. So sort of more that triangle approach that I was talking to on the last slide. Um, Efforts are made to implement when there's an opportunity aligned with maintenance and equipment replacement. So there's some efficiencies there. If you've identified that your boiler is going to be going out in 2030, you might time your HVAC project to go in that time period in order to maximize the use of your existing systems. Um, and then and in this example, you would probably want to have your building envelope improvements get done before your boiler upgrade, so you can basically downsize that boiler as much as possible, um, and basically get your building as airtight as possible. So you can essentially downsize that rather than if you did it after, you would have to build your building for a leaky building, or you'd have to build your boiler for a leaky building envelope, and then um, you would put your boiler in, you would be fine, and then you would fix up the building envelope, and you would then have an oversized boiler and some redundant equipment. So that approach is typically suitable for buildings that remain occupied during upgrades, so you can't take them out of commission at all, and is spread over multiple years. I would say it's probably the most common approach, or at least some version of this is the very uh, common approach, I would say, to most buildings. From advantages, it allows flexibility in financing and planning. It reduces disruption to building occupants. It leverages natural placement costs, like I mentioned, and it can avoid major disruptions to your building. In terms of challenges, it does require long-term planning in order to avoid that lock-in effect or to have those redundant systems, like I was alluding to. And then a lack of long-term strategy can result in suboptimal results. The budget restricted approach focuses on low cost, high impact measures that provide the most bang for buck, basically. Air sealing, lighting, programmable thermostats, and it typically just stops there. We do see a lot of this as well. This is ideal for projects or buildings that are limited budget or funding and need to get stuff done, before they even look at a longer retrofit journey. So it's not everyone's ideal situation, but it's sometimes a necessary approach. It has the advantages of quick savings and immediate savings and quick returns, and it's a quick project. The challenges are it's a limited overall impact in the long term effect, and then you probably will need to revisit your building in the future. It's not going to be something where you can kind of set it and put any future upgrades on a shelf for a while. Just breeze through the last couple, but resilience focused. So that's looking at disaster prone communities and trying to provide a retrofit that addresses their concerns specifically. So if you were in a fire prone community or a flooding prone community, you would be actually retrofitting your building specifically for those climate resilient or those climate emergencies. So the advantage of this, it's going to enhance the safety and reliability during emergencies. It'll often include renewable systems, which is fantastic from an emissions and energy perspective. And then the challenging thing is it's very specialized, often in custom, so it's going to require specialized technologies and partners on the project. Component specific retrofit, I've spoken about, but that's just going after a single component, like your lighting, and doing a deep retrofit of that. So, pulling out all the lighting in your buildings and doing a big LED retrofit with controls and whatnot. So, very simple project scope is an advantage and can be an urgently addressed project. And then once again, another challenge of that is limited overall energy savings and project outcome. So as you can see, there's a lot of different meanings to retrofit and types of retrofits and ways to go about it. Next slide, please. Sorry, next slide, Haley. There we go, retrofit process. Okay, so I will just rip through this one, but basically this isn't written in stone. Every project is a little bit different, but in general, the retrofit process is going to start with this process. Or is going to go through this general process, especially if you have a building portfolio. So you're going to identify all the buildings in your portfolio and all the buildings that you're responsible for. So I know in some communities, Health Canada or Alberta Health Services or someone might manage a building, or a school district might manage a building. So it's important to identify what buildings you're responsible for, what buildings you're responsible for the maintenance, and what buildings you're responsible for the utility costs, and really differentiate those, because that's going to dictate, the upside to retrofitting them, who should be responsible, all that kind of stuff. Once you've done that, you need to benchmark your sites. So that can be as simple as a utility analysis and getting the building type and the size. But really the idea is to determine which buildings are costing the most money, using the most energy, emitting the most greenhouse gas emissions, and then to take that information in the next phase and establish some goals and a bit of a preliminary plan. So depending on your budget, depend on what programs are out there, what kind of targets you may have, that's going to dictate how deep you're going to go into your portfolio, how many buildings you're going to look at, and sort of what the plan is. Depending on what you choose there, regardless if it's one building you're going to retrofit or 10, you are likely going to need to do some sort of energy audit or detailed analysis on the building in order to set the project scope and what's available. So during that energy auditing phase, your consultant will go through, they'll look at the building in its entirety, and then they'll provide you with the projects that that you can go about for your building to be retrofitted. So it'll say, you know, your lights will cost $10,000. To do this, the windows will cost $50,000. And you'll eventually have all these projects that you can pick through and determine, that's within our budget, that aligns with the program, et cetera, and develop a project scope that aligns with the community needs and the data that you've collected through that energy auditing process. So each building is different, has different needs, has a different reality and context. So that energy audit will turn everything into apples to apples. So you can look and say, you can understand what the projects will cost and what their impacts will be. Once you go through that audit and you do that project scoping, like I've talked about, and you've determined which projects you want to go forward with, then you start working to procure and award the project. That will be depending on the project, can be direct to a contractor, can be to an architect, an engineer, depending on the scale of a retrofit. If you're taking your admin building down to its bones and turning it into a daycare, you're probably going to want to work with an architect and a general contractor. If you're just replacing your lights in your daycare, you probably can just award that to your electrical contractor and use the audit to develop, a bit of an RFP or some sort of bidding document. And then, depending on the level of the retrofit, the project will go into some level of engineering and design. Some general contractors will do that in-house, or contractors will do that in-house. Some projects you'll want, a distinct layer of engineering, and then to guide that construction progress. And then following the construction, there's going to be a measurement and verification. That doesn't need to happen necessarily, but it is a good practice to evaluate the success of your retrofit and to make sure that the building is operating in the way that you expected. Next slide, please. Okay, so there's a lot of things to consider when doing a retrofit. And the main thing is there is no one size fits all approach to retrofitting your building. And unfortunately, each building and portfolio is unique, and each portfolio has a different budget, priorities, and all of that. So there is no silver bullet approach. One must take into consider many things and develop a custom approach that works for their building and their community and their portfolio. Something that I've seen done successfully a lot by organizations is creating a retrofit fund. So this is an impactful way to save and budget for energy efficiency projects. It's essentially utilizing the energy savings from your first energy project to build a budget for further projects. So all this requires is an initial investment, so an initial injection of capital to fund the first project. And then theoretically, all projects that follow will build off that initial investment. So if you did a lighting project that costed $100,000 and it saved $15,000 a year, $15,000 a year would go into fund further retrofit projects. And then the project that you did with that $15,000 saves $4,000 a year. So that $4,000, then you can see how it slowly builds a retrofit fund that allows you to retrofit your buildings effectively. And basically without impacting your budget from day one. So you essentially set your budget and then you build off that. You have to consider your building type. Like we go through every type of building, and it's not a standardized thing to go through an office tower and then go through, a fire hall. They're completely different buildings. They have different needs. They have um, different opportunities in them, and based on that, you just have to make sure that you're working with the right contractors who have done that type of work, because certain people might have experience in multifamily homes, and then they might be trying to build an industrial building, and it might not be their sweet spot. So making sure that you've got the right partners for your building type. Building code and regulatory compliance. So retrofit projects should comply with current building codes and standards. This can vary by region, add costs, and depending on the state of the building, it can have a bunch of different implications. So there's more information on that later, but it's something to consider. The operational simplicity, I think a lot of people here can likely, draw on some example where someone got something installed for them that was great in theory, and then they leave the community and no one in the community knows how to operate that system. So when that happens, it's not ideal. So we have to make sure that the systems that we implement have a simplicity and a user friendliness that we can manage as a community. Um, and then, available funding. There's always programs out there for each region. So making sure you're taking advantage of the free money that's out there. Obviously, the budget that you have in your is critical. So how you're going to plan your projects around the budget that you have available is important. The building locations. So we have remote locations in coastal BC. The building completely different need than a building in northern Saskatchewan that is dealing with a harsh Saskatchewan, completely different contractor standpoint, all of that. So yeah, there's a lot to that, and then in terms of occupant needs, each building has different needs, and then as well, buildings you should be carefully considering your material choices to make sure you're using sustainable materials and things that actually work in your region. Once again, different materials should be used in different locations based on the factors and the on. Next slide, please. Next slide, please. Next slide. Oh, sorry, there we go. Okay, so a bit of information on the building code that relates how we construct and retrofit our buildings. For starters, Canada has a national building code that is updated every 5 years, which includes requirements for safety, fire protection, energy, accessibility, and all that. So the code is locally adapted to serve the regional needs, which means we don't have a single code, but rather many codes that fit under the umbrella of a national code. The National Energy Code for Buildings, or NECB, sets the energy efficiency standards for new buildings and major retrofits. There are a lot of details on what this means, but essentially sets standards for the project. This is enforced by the provinces. As you can see by this 2020 image here, different provinces and territories adopt the code at different paces. The NECB is developed federally, but each province will determine if it adopts NECB as it is, adjusts to their local needs, or sets a more strict requirement. Adoption of NECB varies. For instance, BC has its own building codes, like the BC Energy Step Code, which may incorporate or exceed energy NECB requirements. Ontario has its own code. Alberta adopted NECB 2017. So basically, long story short, every province is going to deal with it a bit different, and then so depending which jurisdiction you fall into, you're going to have some different code implications. Next slide, please. Yeah, so this is just a quick slide to show you the timeline of our code adoption, just to show you that it's always changing. The main point here is that it's good practice to try and get ahead of code. We know that there's going to be zero carbon codes in the future. So when you're retrofitting your building, it's important to not only try and get them as efficient as possible, but to consider if the technology you're putting in today will be relevant in 15 years or in 10 years when the code changes. So making sure that you're building your buildings a little bit future proof is very critical to ensure that you adhere to code in the future. Next slide, please. Okay, so building codes impact on the retrofits are very significant in the sense that if you're doing a major upgrade to your building likely should comply with code. It is best practice. This means that there will be structural safety accessibility requirements that you may need to comply with, which will add cost, but also add significant utility to your building as it'll be safer and more accessible and whatnot. The costs do continue to pile up though, so as you need to comply with things you may have not considered, like air quality or fire safety standards, these are really important factors to budget into your project and make sure that your contractors and consultants are considering when they're scoping projects. Finally, building codes can be very, very challenging on cultural and heritage buildings. There may be things, like exposed ceilings and whatnot that are there for a reason. So it's just important to make sure you're engaging with your contractors and the groups that are doing that to make sure that next slide, please. Okay, so diving into a case study that I worked on is the Bearspaw First Nation, which is in southern Alberta, very remote location, probably about an hour from the closest city or about 45 minutes from the closest town. And yeah, so this project, for starters, is about a $1.5 million retrofit that looks into most of the building system, including HVAC, new lighting, building envelope upgrades, solar PV recommissioning, ice plant upgrades, and so on. The project will reduce the energy use of the building by upwards of 70%, and will make the non-operational ice rink, which is, right now the ice is not working, usable again, which provides huge value to a remote community in which, playing hockey is one of the people's favorite things to do. So huge social value in the project, and also provides huge energy savings and opportunities for the community from that standpoint, and to improve a building that's seen better days. So this project received funding through the Green Inclusive Community Building Program in 2021. But prior to that, the building had received an energy audit and community energy plan in 2020 or 2018 and 19 to prepare the community for this retrofit project. So in order to apply for the GICB program, you need an energy audit and energy model. So the community worked with us and with some other partners to evaluate their existing energy audit that had been completed by a different consultant to basically try and turn that into a construction project. So this involved going to site to verify the site conditions, working with contractors to vet and evaluate the project recommendations, tweak things a little bit, change the energy model, and eventually reshape the budget to 2021 standards and develop a new project scope. So a lot of back and forth between a bunch of parties. And about a year later, the project receives funding. Engineering and design followed. This project received, like I said, 1.5 million of federal funding, but it did not come without challenges, which I'll get into in the next slide. Next slide, please. Okay, so as mentioned, this went through a very long timeline. So the market conditions changed. So HVAC prices in that time went way up. Ice plant prices went way up. And honestly, the condition of the building continued to deteriorate over that 4-year period. So um, it um, it really did go through a lot of changes and challenges. And then, another thing that was a big challenge was there was so many different parties involved that there's a natural lack of continuity in the product. So, an energy audit done by one group recommends something, another group picks it up and says, well, no, that doesn't make sense. That we think you should do that. Then it gets handed to the contractors. They say something else. Then it gets to the engineers, and it's just a very broken process at that point. So, in as much as possible, getting all your parties onboarded early, and so there's alignment is a huge benefit for a project. The remote location was considered, but probably not the challenges that came with it to the full extent. So, contractors wanted additional money to even bid the project and go to site. It was challenging to get, lodging for the contractors and whatnot. So some of these considerations helped definitely provide some lessons learned. Um, the solar array, I mean, this was good from an energy perspective because we were able to, identify a big need and a big problem, but it's because the solar array wasn't turned on when we went there. They had an 80 kilowatt solar array that was not on, and it had 2.5 years. So, that's thousands of dollars of lost opportunity cost, and all, that definitely a big challenge there. And then there was very limited skilled labor in the community. So we had to go use pretty much all outside contractors. And then the general condition of the building was getting worse. People were breaking into the building and vandalizing the building and things like that. So there were added costs in terms of safety and code and things like that. Next slide, please. Just going to speed up the pace a little bit. I'm just looking at the clock here. So for lessons learned, um, you know, there were a lot. I kind of talked about them, but the need for a community champion is critical. It's probably the most important thing on any remote energy project. Someone within the community who takes ownership of the project, fills the gaps needed. That could be meeting contractors, taking a picture of a utility meter, or engaging with the community. I can't really emphasize how important this is in making a successful project. In terms of costing and applications, I mentioned that you're going to want to put in large contingencies, put in for increases in the future, and make sure that you budget more than enough for the project. Um, in terms of remote locations, um, make sure you consider all those things. It is a pretty large price increase to do work in a remote location for contractors. So we need to make sure we're aware of that at the application stage. In order to get a project funded, you pretty much always need some sort of document that shows the impacts of the project. So while if you can get funding for energy audits and things like that, it's always important to have that data at your fingertips. So when programs come out, you can access that. And yeah, as much as possible, try and bring your project partners on from the start. Um, it's just going to create more continuity and more alignment in the overall project execution. And then if you do want to engage the local working force of your community, I think it's really important that that get done early in the project. You set that precedent, and then that community champion works with the contractors and consultants to make sure those people are effectively onboarded and trained. and you make sure that there's an accountability and a feedback loop for that, because often we see community engagement and training get done sort of on the side of the desk, and there's not as large of an impact as there can be. And yeah, try and make sure that we're monitoring and operating our equipment. The solar had been installed years ago and had been off for years. So, you know, that the big lesson there is we need to make sure someone's looking into our solar arrays and things like that when we're installing them. And then, yeah, no two projects are the same, as I mentioned. So I won't go more into that, but it's projects very distinct. Next slide, please. Okay, I'm just going to rip through this one, but again, the barriers are pretty vast. So we have to make sure we know what the barriers to our retrofit project are in order to combat them and execute the project effectively. So access to data and information such as energy audits, building conditions, and stuff, accessible or they're not in place. So we need to start from scratch. And yeah, it's important that that gets done. There's often a challenge getting information from the community. This is because a lot of the community employees are maxed out. They're doing a million things, and to go collect 15 sets of utility bills is just a lot for them. So that's a big challenge. That kind of ties into the capacity. There's often limited internal capacity from the staff, and you know it can be a challenge for a retrofit project or an energy project to get prioritized, which further emphasizes the need for that community champion. And then the condition of the buildings are typically largely behind code, which makes them you know very costly to retrofit. There's the high reliance on consultants and lack of data sovereignty. So often, you know, the community won't have all the information needed, so they'll need to pay another consultant to do things, which just adds another layer of complexity and cost. And then for training, low budgets, and low financial literacy can impact that. Next slide, please. So this is a bit of a standalone slide, but it's something I find very important. Energy efficiency, when used effectively, can be used as a vehicle to communities to do so many different things. Why do they have utility savings and environmental impact? You can create local workplace development and economic development. You can better your buildings and improve the places that you work, live, and play. You can create an increased sense of community pride and unity through nice functional buildings. You can make these buildings align with your values, and then in general, the poverty both on the houses and on the community level is critical to make sure people aren't spending all their money on utility bills, or relying on utility companies, and become more self-sufficient as a community. Next slide, please. Sorry, next slide. Oh, there we go. So yeah, major ways to fund a project: be free money, government incentives, third-party financing, so energy service contracts. So that's people who will give you financing and they'll pay themselves through the energy savings of a project. Self-funded, so paying out of pocket, and then partnerships with private sector. So you can become the, you know, X, you know, bank center for performance or something like that. So, you know, partners with private sector, and then a combined approach. I mentioned fund. Next slide, please. You could do a full presentation on all programs. Um, they're regionally dependent, so you have to make sure that you're in the right spot for the right program. But there's Clean BC, there's the Four Winds program in Alberta, there's the Cedar program in BC, programs in Ontario. So point being here, it's very much determined by the region that you're in, but there are likely programs that you qualify for to help you retrofit your buildings. Next slide. So we have pretty limited in Alberta to the Deep Retrofit Accelerator program in Alberta. You can reach out to me like more information on it. Does provide funding for a lot of the activities we're talking about. So energy audits, benchmarking, energy engineering on your buildings. There's a coaching and support software. So it really is a high impact, 100% funded project that's accessible to all Alberta Indigenous communities and organizations. It's available till March 2027. But yeah, or what have you about that, because we're coming to the end. Next slide. Basically, this is how the program works. I won't spend too much time on that, but the list, you submit a list of your buildings, they get benchmarked, the buildings that qualify get audited, then they go into an energy management software, and then the highest priority engineering project gets funded, and then we try and support finding actual funding for the construction of the project. So it's designed for deep energy retrofits of your buildings. Next slide, please. The program does have a workforce training component where Indigenous people can be hired and trained to be energy analysts. So far, 3 people, or there's actually 4 people who have been trained and are working on audits in communities from different communities throughout Alberta. So it's a very sweet project from that standpoint. But yeah, so if there are any people within an Alberta community that are seeking work in this field, there's an opportunity for them to find work through this program until 2027. Next slide. And that's all for me. I do apologize about my technical difficulties throughout, but hopefully most of that got through. Yeah, happy to answer any questions that have been gone into the chat box.
Thank you, Adam. We do have a few questions. So Andrea asks, does the NRC audit for residential homes including pricing?
Sorry, the
NRCan?
NRCan energy audit include
Residential homes. Does the NRCan
no.
audit for residential homes include pricing?
Sorry, it doesn't qualify for any homes. It qualifies for all commercial and community buildings, but it won't do single family. And it funds all activities basically other than construction.
Okay,
So in the
thanks.
energy audit, the costing of projects, some of the engineering.
Okay, does it have a hierarchy of what should be done first?
In that program, it goes through the process of um, benchmarking the buildings and then auditing them and then putting them into an energy management software and then following that the most high engineering project by the community that gets funded. So that could be recommissioning your solar array or doing a custom retrofit package on your arena. So it kind of depends on the
Awesome. Someone asked if current condition would include identifying suspected issues like mold.
Yeah, and that's one of the important things that should get discussed with whoever you're working with is if you suspect that there's building deficiencies that you're going to want to put into the scope, make sure that those get identified. Because in the standard scope of an energy audit, they're not looking for mold or asbestos or things like that. So um, they'll note it if it's seen within the inspection, but an energy auditor isn't trained to look at those things necessarily. So they may need to bring in support or work with partners in order to effectively mitigate those health concerns. So yeah, it's the more integrated a project, the better, and the more um, transparent the communication is from the start, from the community or from the building owner, the better. Because you know, if you say, "Oh, we're doing this retrofit project," and then once it's funded, they go, yeah, and we need to get our fire alarm, probably identify that in their audit because it's not, part of what they're looking at. And then now you've got a fire alarm project that has been brought to the team after the budget's been set and the scope has been set. So the more open and transparent the communication can be early, the better that we can make sure that these things get identified and dealt with.
Thank you. Last question. Do you have suggestions for creating future-proof buildings? Is there training out there or standards that would be relevant to Alberta?
Yeah, I mean, I could talk for days about future-proofing buildings. In terms of a single standard, nothing comes to mind. I think there are some CAGBC has come up with some standards, but I wouldn't want to put one standard above all. But there are some standards for net zero and things like that that have come out that are definitely progressive. But in terms of future-proofing, the main consideration that I would say is um, making sure that you're not installing redundant HVAC systems that won't be relevant or things like geosystems, air source heat pumps in the future. For example, if you just install high efficiency furnaces that are going to be good for 30 years, that's going to prevent you from ever getting your building to a really high efficiency level because you're going to be reluctant to pull out functioning furnaces that you spent a bunch of money on that are still pretty decent, for example. It's, I didn't get to talk too much about this, but the material selection when it comes to climate resiliency, I think, we're seeing a lot of fires and floods and things like that. Future proofing your building for what's most relevant to your region from a climate resiliency standpoint is super critical. So that, fireproof building envelopes, fire retention walls, things like that. Those are super critical in future proofing your building for what, what over the next 25 years, 50 years. So those would be some of the things, but happy to talk in more detail about future-proofing buildings for a specific area in Alberta, because like I said, it is very much even within Alberta, different zones and northern and southern.
Awesome. Thank you, Adam. And thank you everyone for coming. We're just going to wrap up here. If you have any other questions that you didn't have a chance to submit or didn't get answered, feel free to email Adam. His email is just up on the screen there. Have a great day. Stay tuned for any upcoming webinars we have. Check out the Bear Training Facebook group if you're interested in that, and have a great day. Thank you.